Hello, we are Group 13. Today we will explain key concepts from Topic 3.2, Budget Constraint, Preferences, Indifference Curves, Marginal Rate of Substitution, and Utility Function. These are essentials for understanding how consumers make decisions to maximize satisfaction under limited resources.
Hello, my name is Kauta and I'm going to talk about the first part of the project, preferences. Okay, so let's assume that the consumer knows what he wants. That is a preference. Preferences would be based on the utility on how attractive the product is to the consumer. We then note a preference relation with the symbol percentage. There are many preferences properties, but we are going to focus on 4. Completeness, transitivity, monotonicity, and convexity. The first one, completeness, we can say that a preference is complete if the individual can compare any two options, A and B, deciding that either A is preferred to B or that B is preferred to A. The individual is indifferent between A and B. In the second one, we say that a preference relation is transitive if A is preferred to B, B is preferred to C, and C is preferred to A. It is an important property because without it would be difficult to represent it in a mathematical way. The third one, monotonicity, it's the easiest one. So it says that the more we have, the better. So the more we have of a product, the better for the consumer. The fourth one, convexity, means that a balanced bundle is better than an extreme one. To represent the preference relation, we will use the XY plane and two tools that would be the indifference curves that represents a set of bundles that gives the same level of satisfaction, and the utility function is the mathematical representation of the preference relation through a function.
Indifference curves represent all possible combinations of two goods that provide the same level of satisfaction. They are downward sloping and convex due to the marginal rate of substitution, as it is shown on the first example on the right. If the goods are perfect substitutes, these curves will be straight lines, because the consumer is willing to exchange them at a 1-to-1 ratio, as it is shown on the second example on the right, the green one. If the goods are perfect complements, like a left shoe and a right shoe, these curves will form right angles, as it is shown on the third example on the right, the blue one.
Point 3. Marginal rate of substitution. The marginal rate of substitution refers to the rate at which a consumer is willing to exchange one unit of good X for an additional unit of good Y while maintaining the same level of utility. The indifference curves of this function are not straight lines. That means that they are convex, and this convexity reflects the consumer's greater willingness to give up a good that she already has a lot of it. As I said before, they are not straight, so this marginal rate of substitution is not the same in all points on a given indifference curve. The rate at which a consumer is willing to trade one good for the other depends on the amount of the good that she is already consuming. Mathematically, is expressed by this expression: y is equal to the partial derivative of y divided by the partial derivative of x for each. This rate corresponds to the slope of the indifference curves. The marginal rate of substitution is negative because as the amount of one good decreases, the amount of the other good must increase to keep the consumer equally satisfied. If not, it wouldn't make sense. The example of a perfect substitute. So two goods are considered perfect substitutes when one unit of a good can be replaced by a fixed amount of the other good without affecting the consumer's satisfaction. It means utility. In this case, the marginal rate of substitution between both goods remains constant. By the other hand, the perfect complements in this case is different because the two goods cannot substitute for each other at all. So to achieve satisfaction, the consumer requires a specific fixed ratio of both goods. As a result, increasing the quantity of one good alone does not automatically lead to higher utility. The marginal rate of substitution between the two goods is either undefined or equal to zero. And then there is an example that expresses this case, that gloves for left and right hands. If you have one glove for each hand, adding an extra left hand glove does not increase your utility, because you still need a matching right hand glove, so it will make a difference. And that would be the example.
Now I am going to talk about the utility function. The utility function is a core concept in microeconomics that represents how consumers rank their preferences for various combinations of goods or services. It serves as a mathematical tool that captures the satisfaction or happiness consumers get from consuming specific bundles. However, utility is ordinal, meaning it doesn't measure the intensity of satisfaction but simply indicates a ranking. For instance, if one bundle of goods has a higher utility value than another, it means the consumer prefers it, but the numerical difference doesn't reflect how much more it is preferred. Then I'm going to talk about the importance of utility function, which are vital for understanding consumer decision making, like the way consumers allocate their limited resources, such as income, to maximize satisfaction. This concept is explained by the consumer choice theory, which explains how individuals decide between different combinations of goods based on their budget constraints and preference. Then we have the transformation of flexibility, which is a unique feature of utility function, is their invariance under monotonic transformations. Then we have the applications of utility functions, which are used to derive demand curves, which illustrate how the quantity of a good demanded changes with its price. They are also key to understanding concepts like the marginal rate of substitution. In addition, utility functions are used to analyze how consumers respond to changes in income, price, or the availability of substitutes and complements. Finally, I'm going to explain the three types of utility function. First, we have the linear utility functions that assume perfect substitutability between goods. Then we have the Cobb-Douglas utility function that model preferences where goods are consumed in specific proportions after reflecting diminishing marginal utility for each good. And finally, we have the quasi-linear utility functions that assume one good has a linear utility while others exhibit diminishing returns, making them useful for modeling scenarios like public goods or savings.
To conclude, the concepts we've discussed, preferences, indifference curves, marginal rate of substitution, and utility function, are fundamental in understanding consumer behavior. They explain how individuals make rational decisions to allocate limited resources effectively, balancing their preferences and maximizing their satisfaction. By analyzing these concepts, we see how economic theory connects to real life decisions such as choosing between goods or adjusting to changes in income or prices. These tools also forms the basis for further studies in microeconomics such as market dynamics and policy analysis. Thank you for watching our video. We hope it has been insightful and helps you better understand these essential microeconomic principles.